Okay, so today we are going to discuss about half subtractor. So before that, let us have a small recap about the previous class. So in the previous class, we have studied about the combinational circuit. So what is combinational circuit? What is combinational circuit? So for combinational circuit, the output depends only on the input. So no memory and no feedback loop is required. Okay. Examples of combinational circuit: adder, subtractor, multiplexer, demultiplexer. Okay. Okay. So in the last class we discussed half adder and full adder. Okay. What is half adder? Anyone can answer?
And the output is different.
Sum and carry. Half adder and sum and carry. Okay, very good. Sit down. What is full adder? Okay, sit down. So half adder, if we want to add two numbers, we can use half adder. The main problem in half adder is it cannot include or it cannot add the carry. Okay. So for that we prefer full adder circuit. It accepts three inputs, that is A, B and C. Okay, the carry of the previous. Okay. So likewise, today we are going to discuss half subtract. Okay. So the main that is empathy of using, that is why we need half subtractor means to perform ALU operation in combinational circuit. So what is ALU? What is ALU? Arithmetic and logical operations. Okay. So in combinational circuit, we use half subtractor, half adder. So the half subtractor is mainly used to subtract two binary numbers. Okay. So this is your half subtractor. That is, it accepts two inputs A and B, and the outputs are difference and borrow. Okay, so this is the first step. That is, the first step of combinational circuit are define input and output. Okay, here we are defining two inputs and two outputs. Okay, so as observing the list, we have to list the input and output. That is, we have to make the truth table. So I already told that for n inputs we can 2 power n possible outputs. So here how many inputs are available? 2 inputs. So there are four possible combinations of output. That is 0 0, 0 1, 1 0 and 1 1. Okay. So the outputs are difference and borrow. That is out, borrow out. Okay. So if we subtract 0 and 0, the difference is 0. So is there any borrow? No. So the borrow also 0. So if we subtract 0 and 1, that is from 0 we are subtracting 1. So we have to borrow 1 from the previous one. Okay. So that is a borrow, and so if we borrow 1, it is 10 minus 1. So what is the output of 10 minus 1? That is 1. So the difference is 1 and the borrow is also 1. The next one is 1 minus 0. So the difference is 1. Any borrow? No borrow. Next one is 1 minus 1. The difference is 0 and the borrow is also 0. So this is the second step. We have completed second step, that is we have defined the truth table. Okay. So what is the third step? Boolean expression. So we can do the Boolean expression by using SOP or POS form. What is SOP? Sum of. What is POS? So here we will use SOP form, that is mid form. How can we take the Boolean expression? We have to see the output, okay, and we will take the expression where the output is 1. Here, the output is 1, that is 0, that is A bar and B, and also A, B bar. Okay. So the difference is A bar, 0 means A bar, 1 na B. Then the next output A, B bar. So it is in the form of XOR gate. So we can write A XOR B. That is the difference of half adder is A XOR B. Next we have to take B out. Okay? Only one output is high. Then A bar B. Okay, A bar B. That is A bar B. So what is the last step? The step one is designing the logic gate. So for difference, we have a B out. We have to, what is the output for B out? A into B. For A into B, we can use AND gate. Okay, but there is A is in complement form, so we have to use NOT gate. Okay, so from A, we can take on NOT gate and directly we can use the A input. So this is your difference, that is A XOR B. This is your borrow. Okay. Here A bar, A and NOT gate A bar. This is your B, so A bar. Okay. Okay.
So today's topic is half subtractor. So what is meant by half subtractor? It used to subtract two binary numbers and used to perform arithmetical and logical operators in combinational circuit. So there are four steps. First one define input and output and truth table and Boolean expression and logical gate designing. So we are using two input A and B and two output difference and borrow. By putting the truth table, we will get zeros and ones. So by calculating, we will put zeros and ones. By Boolean expression, we will get the Boolean expression like where in output where we are getting ones, we have to take that expression A dash B plus A bar B plus A B bar. So this is the expression of XOR gate. So it is A plus B. So A XOR B. So then carry.
So this is the symbol for XOR to represent XOR.
In B out there is an output 0 and 1 which is A bar B. In step 4 we are designing logical gate. We are drawing A and B and then giving a NOT gate to get an A bar symbol. Then we are getting the answer.